Oh, hello everyone, and welcome to the problem solving video for April 6th. Today we're focusing on the thermochemistry problem on slide 29, which is really a heat capacity question. The idea that the amount of heat required to change the temperature by that heat either coming into something, raising the temperature, or the heat leaving something, the temperature of that object cooling off, is directly related to the amount of substance and the thing we call the heat capacity, the ability for something to hold heat before it changes its temperature. In this question, we're talking about raising the temperature of 237 grams of cold water from 4.0 degrees Celsius to 37.0 degrees Celsius. So really the way to think about this problem is the amount of heat required to raise 1 cup of water taken from your refrigerator. What's the amount of heat your body puts into that cup of water to raise it to your body temperature, let's say inside your stomach? So in this particular case, what we would find is we're going to use the idea that the amount of heat is related to the mass of the water, the thing that we call the heat capacity, in this case the specific heat capacity for water, and then the change in temperature that the water undergoes. Now in this particular case, change in temperature is very importantly always the final temperature minus the initial temperature. This is going to be very important in terms of signs in the thermochemistry problem solving, because when you again raise the temperature of something, you've put the heat into something, and when something cools off, its temperature goes down, the heat has been removed. And so that's going to tell us a whole lot about the signs of things. So in this particular case, we're talking about 237 grams of water. The heat capacity of water happens to be 4.184 joules per gram per Kelvin or degrees Celsius. Turns out those are interchangeable in this case, because we're going to find out that when we're talking about changes in temperature, that's the one time we could leave things in degrees Celsius and get the same answer. Of course, I'm going to do that here, because what we're going to find is, look, if I take 37.0 degrees Celsius and convert that to Kelvin, I'm going to add 273 to that. If I then subtract 4 degrees Celsius, which I've converted into Kelvin, then what you're going to find out is I'm going to have added 273 to that, and those added 273s are going to cancel each other out. The difference between 37 and 4 degrees and 310 and 277 Kelvin is going to end up being exactly the same in terms of size. That's why delta T can be done in this particular case in degrees Celsius, which means I could change this to degrees Celsius here, I'd be fine. Do that here. Here we go. So yeah, we're going to have 237 grams times 4.184 joules per gram per degree Celsius, and that's going to be multiplied by the 33.0 degrees Celsius increase in temperature that the water is going to have to undergo as it warms up in your stomach after you've taken that nice cool drink out of the refrigerator. So let's get the calculator on the go. We're going to see that there's 237 grams times 4.184 times 33. And what we're going to see is we're going to get something like, let's see, going to be 3 sig figs in this answer, so we're going to get 3.27, let's say sub 2 if we wanted to use this in a later calculation, times 10 to the 1, 2, 3, 4. And what we're going to see is, of course, degrees Celsius cancels out per degree Celsius per gram here. Wrote my unit down incorrectly. I'm going to cancel out the gram here, leaving us with joules. There we go. Question is asked for this answer in kilojoules, so this is going to be 3.27 sub 2 times 10 to the 1 kilojoules, which is 32.7 kilojoules. So yeah, heating up the water in your body, this 1 cup of cold water in your body that came from the fridge, it's going to take the equivalent in food energy to about 4 Tic Tacs to do that. So that's the idea of heat capacity and how you can use it to solve for a problem. Tomorrow's problem, we're going to be using a very similar idea, but it's going to be the masses and heat capacities of two different substances and seeing how we end up figuring out a final temperature. But we'll see that tomorrow. So that's been today's problem solving. Have a good one, everyone, and I'll see you soon.